I'm sure in your studies of chemistry so far you've heard about the mole, and well, here it is. So particles are really small, and by particles we mean atoms, ions, molecules, really small. So if we want to be dealing with them as we do in chemistry, we have to deal with a whole lot of them. So if we want to react one substance with another substance, you're going to have a whole lot of these tiny little particles doing their thing. So we need to think of them, or it helps to think of them, in a group. Avogadro, this fellow here, came up with the idea of grouping these particles into a particularly sized group, and that is where we got the idea of the mole from. As an analogy, let's look at eggs versus particles. So eggs, chicken eggs, we use them to do different things. We buy several of them at a time. We tend not to buy one egg at a time. We tend to use a number of them at a given time, so we tend to buy groups of them. And the group that we have decided on for eggs is a dozen. Particles, they also are going to be reacting in groups. There's going to be huge amounts of them going through the same reactions around the same time. So again, it's not just one of them that we're dealing with. So for eggs, we have decided to go with a dozen as a grouping, 12 of them in a group that we have referred to as a dozen. For particles, we have decided to put them into a group as well, not a group of 12, because 12 isn't that many when you're dealing with small particles. So instead we've chosen a larger group, and we call that grouping a mole. So just as a dozen is a certain group, a mole is a certain group. So a dozen is a good amount, a manageable amount of eggs based on how big they are and how we use them. So we tend to collect things like eggs and donuts and muffins into this group that we refer to as a dozen, which is 12 of them. Moles, because particles are so small themselves, moles have a lot of particles in them. But a mole is a manageable amount of those particles based on the fact that the particles themselves are so small. A dozen of one thing, that doesn't matter what it is, it doesn't matter whether it's eggs or donuts or muffins, a dozen is going to be 12 things. So the name of the group is a dozen, the amount of things in it is 12. In chemistry, we have a group. The group's name is called the mole, and because it deals with very small things, we put a lot into that grouping. So a dozen has 12 things in it. A mole has 6.022 times 10 to the 23 things in it. So to be clear, a mole has 6.022 times 10 to the 23 things in it. It is just a group, and the size of that group is 6.022 times 10 to the 23. We have 4 significant digits here, so that gives us lots of precision. We won't be limited by the precision of our number of things in a mole. Plus 22 will help you remember the exponent on the 10, which is 23. So 6.022 times 10 to the 23. A pair of atoms, if you had a pair of atoms, you would have 2 atoms. A dozen atoms, if you happen to have a dozen of them, you would have 12 of them. If you had a mole of atoms, you would have 6.022 times 10 to the 23 atoms. Big number, but again, the name of the group is called a mole. The number of things in that particular group is 6.022 times 10 to the 23. That's what a mole is. In chemistry, we like to save as much time as we can, so mole is the name of the unit, but when we're writing it, we abbreviate it as mole. We drop the E, it saves dozens of seconds. So if we were talking about 3 moles, we could write it as 3 mole. We'd still say moles. So a mole of particles contains 6.022 times 10 to the 23 particles in it. For example, if you had 1 mole of carbon, you would have 6.022 times 10 to the 23 atoms of carbon. If you had a mole of water, you would have 6.022 times 10 to the 23 molecules of water. And if there is 1 mole of sodium chloride, you would have 6.022 times 10 to the 23 formula units, not, there we are, formula units, because remember this is not a compound, does not hang out like a molecule does as an individual unit, but you have this crystal lattice structure of repeating sodium ions, and chloride ions. So we refer to those as formula units, but you would have 6.022 times 10 to the 23 of those. So this idea of using a particular sized group to quantify particles, that was Amedeo Avogadro's idea, and hence the idea of the mole came from him. This is referred to, this ratio of 6.022 times 10 to the 23 particles is 1 mole, is referred to as Avogadro's number. So 6.022 times 10 to the 23 is Avogadro's number. It gives the symbol N subscript capital A, capital M. That's referred to as Avogadro's number. Now, being as it is a ratio, we're going to use it as such, and this now allows us to convert between moles and particles. If you had 1 mole, you'd have 6.022 times 10 to the 23 particles. If you had 2 moles, you'd have twice that number of particles. Since we're using conversion factors to convert from one thing to another, you can write this out. So if you had a number that you wanted to multiply that was in moles, so let's say you had 2 moles, you could then multiply that by this conversion factor. The units of moles would cancel out, and your answer would be in particles. Or you could use the conversion factor like below here. If you were in particles and you wanted to cancel out particles, you put it on the bottom. It's the same ratio, just used different ways depending on what you wanted to convert. For example, if you had 0.500 moles and you wanted to convert it into atoms, so we want to find out how many atoms are in 0.500 moles, we could set up a conversion factor just like we were doing before, where you put the unit of the thing you don't want on the bottom. So when you multiply your quantity by that, the units of moles will cancel out, and we want to convert to units of atoms, and we know the ratio is that 1 mole has 6.022 times 10 to the 23 atoms in it. So moles will cancel out, the unit of atoms will carry through to the end, and then we pick up our calculator if you need to, and you multiply 0.500 times 6.022 times 10 to the 23. This is actually a good idea, good time to practice using your EXP button. But if you put 0.5 times 6.022 exponent 23 into your calculator, it should spit out the answer of 3 half of the amount, 0.011 times 10 to the 23. If you've gotten 24 instead of 23, you've not put in, and again remember you're using your EXP button on your calculator. When you go to put in this times 10 right here, you're not writing in multiplied by 10, you're hitting your EXP button or your EE button depending on which calculator you have, or maybe your calculator may even have a times 10 button on it, but either way you're not writing in multiplied by 10. On the other side, if we have sulfur here, we have 1.8 times 10 to the 24. Writing with a mouse is not easy. And this is atoms is the quantity, so always write the unit on the number that you're dealing with. And if we multiply that by a conversion factor, we're trying to find out what is the number of moles. We have the number of atoms, so that's the one we put on the bottom. And we put the moles up top. That's moles. And we then drop in the numbers. 1 mole we know has 6.022 times 10 to the 23. And we know that atoms will cancel out as a unit, and our answer will be in moles. And so you can put this in your calculator, 1.8 EXP, so you don't hit times 10, just put EXP 24. And if you'd like, you can multiply that by 1, and you know the answer to that, and you can divide that by 6.022 exponent 23, and you should end up with, again, we have about 3 times the amount of atoms here, So our final answer is about, oh, I'm going to write that at 2.9890, so on. But remember, we're going into the calculation with only 2 significant digits. So we're going to have to round our answer to 2 significant digits. So this is going to be rounded up to 3.0 moles. So again, use the conversion factor to convert between moles and atoms, and the ratio that you're using for this is Avogadro's number, the fact that we have decided 1 mole will have 6.022 times 10 to the 23 atoms in it.